Today we will be solving systems of equations using the substitution method. So our objective today is that students will be able to solve systems of equations by using the substitution method. So in our previous lesson we graphed and we looked to see where the two lines crossed. Today we're going to use an algebraic method. An algebraic method is nice for two reasons. Number one, if you're graphing and your point of intersection happens to be at a fraction or a decimal, that is very hard, almost impossible to read from a graph unless your scale is appropriately set up. So we need another method. So an algebraic method works really well, and what we're going to do today is we're going to use something called substitution. Now substitution is nice because basically what you're doing is ESA, not once but twice. For those of you who are not familiar with ESA, that means we have an equation, we substitute in and get an answer. We're going to do that not once, but twice. So let's get started. Okay, in this problem, we have two equations. We have this equation, and we have this one right here. In our steps, what we need to do is we need to get one variable all by itself. And it doesn't matter which equation we go for. If I look at the two equations, this equation is the easiest to work with, and it's easier to get the y by itself. Because to get the y by itself, all I have to do is add 2x to both sides. And I end up getting y is equal to 2x minus 1. Now I have one variable all by itself. Now this is the cool part. What I'm going to do is I'm going to take this and I'm going to put it into the other equation. So I'm going to do ESA. So the other equation is 4x plus 3y equals 27. This is my E. And now I am going to take this expression right here and I'm going to put it right in place of the y. The reason I do that, it is the same value as y. In other words, if y is 50, then 2x minus 1 is also 50. If y is 1,000, then the expression 2x minus 1 is also 1,000. If y happens to represent 0.75, then the expression 2x minus 1 also is equivalent to 0.75. They are the exact same value. So all I'm doing is I'm replacing the variable for an expression. Now, the reason why that works so well is now when I look at this equation, I have an equation that just has one variable in it. It's all x's. So it makes it very easy. All I do is solve this and I'm going to get my value for x. So let's use our distributive property here. So I have my first part of my answer, x is equal to 3. Now, the next wonderful thing is that we're going to take this 3. We're going to take this 3 and we're going to put it back up into either one of the two original equations. Either one, it doesn't matter. Because remember, this is the ordered pair that works in both equations. So I should be able to take that 3 and put it into either one. And actually, I can put it into either one of the originals or the one that we rewrote, because the one that we rewrote is equivalent to the original. And I actually think that's the one that I'm going to use here. I think I'm going to take this one right here. I'm going to use that one. I like that one. So I'm going to take the y equals 2x minus 1. And now I'm going to substitute in 3 for my x. I'm going to put 3 right in where my x goes. So now I end up with y is equal to 2 times 3 minus 1. So y is equal to 6 minus 1, which means y must be 5. So this would cross at the ordered pair 3, 5. And just like in the previous lesson, if you want to check, all you have to do is put those values into your equations. And I would go with the originals on this one. So let's see, 4x plus 3y equals 27. Okay, so I'm going to put 4 times 3 make that look like a times, plus 3 times 5 equals 27. I'm not quite sure where the red ink is coming from. So 12 plus 15, does 12 plus 15 equal 27? It does. All right, I'm going to do this again. My other equation was y minus 2x equals negative 1. Okay, so let's see, that's going to be 5 minus 2 times 3 equals negative 1. 5 minus 6 equals negative 1, and negative 1 does equal negative 1. That is true. All right, let's try this again, for those of you who are not sure. So let's see, example, solve and check the system of equation. So we need to get one variable all by itself, just one. And I'm looking at this and I'm thinking that this variable is the easiest to solve for. So I think I'm going to move the 2y over. So now I get x is equal to 2 minus 2y. So whatever x is, 2y is the exact same, 2 minus 2y is the exact same value. So again, if x happens to be 10, then the expression 2 minus 2y is also 10. If x happens to be 3, then the expression 2 minus 2y is also 3. X and the expression are the exact same value. So what we're going to do with that is we're going to take that and we're going to put it in this other equation. So we have 3x minus 4y is 26. And I'm going to take this expression right here, because it's equal to y, and I'm going to put it right in for this x. Okay. And then all you do from here is solve. So we'll use our distributive property. And it looks like I'm coming out with y is equal to negative 2. I hope that's right. Okay, that's our first ESA. Now we're going to do our second ESA. So I'm going to take this equation, and it can be any one of the three equations. I just chose this one because it looked easier to me. But you can choose any equation that you want, either one of the two originals or the one that we rewrote. With substitution, the one that you rewrote is usually the easiest one. Okay, so now x is equal to 2 plus 4, so that means x is equal to 6. I can do a quick check. So we have 3x minus 4y is 26. Let's see. 3 times 6 minus 4 times negative 2 equals 26. Let's see if I can get rid of that. I am not sure where that red is coming from, so let me plug. Okay. So 3 times 6 minus 4 times negative 2, we're hoping is 26. 18 plus 8 equals 26, and I believe that is true. And now I can do my other one. X plus 2y is 2. So that would mean, let's see, we have 6 plus 2 times negative 2 equals 26. So 6 is equal to 2 plus 4, and yes, 6 does equal 6. All right, let's try another one. Okay, so the first thing is you need to get one variable all by itself. I'm looking at the first equation, it looks way too complicated. So I think I'm going to go with the second equation, and I'm going to move I think what I'm going to do is I think I'm going to move the x to this side. And I think at the same time, I think I'm going to move the 5y over. So now I have x is equal to 13 minus 5y. Okay, so let's begin. We're going to start with our first ESA. We're going to take one of the equations here, and it has to be the other one. And I am going to plug this expression right in for x, because x and the expression are the same value. Okay, so now we're going to use our distributive property here. So 5 times 13, well 5 times 10 is 50. 5 times 3 is 15, so that must mean this is 65 minus 25y minus 3y is equal to 9. So we have 65 minus 28y is equal to 9. So let's minus the 65 from both sides. And I have negative 28y is equal to uh-oh. Well, running into a little bit of technical issue here. So we have negative 28y is equal to negative 56. Divide both sides by negative 28. And looks like y must be 2. Box that. We are good. So now let's find our second variable. And it's easier to use the one that you rewrote. And I'm going to put that 2 right in there. So I'll put the 2 right there. So x is equal to 13 minus 10. X is equal to 3. Now I'm going to pause the video and do a quick check just to make sure, and you can see my check. So I'm going to pause the video now. So I just did my check, and you can clearly see that it works. Okay, let's do another one here. Let's try this one. We need one variable all by itself. Well, I think what I'd like to do is I'd like to get my y by itself in this equation. And there's a reason that I want to do that. So I'm going to move the x and move the 2 over. So I end up with y is equal to negative x minus 2. Now I'm going to put that in the other equation. The reason that I did it this way is that I wanted to show you something. What I wanted to show you is that when I plug this in for y, the negative x minus 2, I have a subtraction sign in front of the y. What that means is I need to have parentheses. If I don't put the parentheses around the binomial negative x minus 2, I'm not going to distribute the subtraction. And it is minus a binomial. So I have to have that in there. So it becomes x plus 2 is equal to negative 8. 2x plus 2 is equal to negative 8. X is equal to negative 10, which means x must be negative 5. Okay, so I think I will plug that into this equation right here. Negative 5 minus 2, so y is equal to 5 minus 2, so y must be 3. My check could be really fast. X plus y plus 2 is 0. So negative 5 plus 3 plus 2 is 0. And yes, that does equal 0. X minus y is negative 8. So negative 5 minus 3, yep, that's negative 8. Check. Now, I have a couple other problems. If you want to try it, you can pause the video, and I'll put the answers up, and you can see if you did it correct. So this is the first one. So go ahead and pause the video. If you want to try it on your own, when you unpause it, I'll have the answer. Okay, so if you did it, you should have x equals 5 and y equals 2. And this was easy enough to do a mental check. X plus y is 7, so if I add 2 and 5, I do get 7. And 2x minus y should be 8, so if I double 5, 5 times 2 is 10. 10 minus 2 is 8. So that was an easy enough one to do a mental check. If you'd like to try one more, there is one more here. If you feel like you have it, we can get right to the practice. But I'm going to pause the video right now, or you can pause the video right now if you wanted to try this. So the correct answer here is negative 4 and negative 2. And I did check both of them. They do work. So now, if you are ready, you can do the independent practice. Your independent practice will be on page 412. And I want you to do 9 through 39. But again, I only want you to do multiples of 3. So that means you're going to do 9, 12, 15, 18, 21, and so on. Now, just so that you're aware, there are 10 lessons, but we have more than 10 days. So if you need to take the day to finish some lessons, that's fine. So I want you to work 30 minutes a day, but whatever you don't finish up with, you can work on, say, the next day, or take a day at the end of the week and maybe do anything that you didn't get a chance to do. So we've got a few extra days in here. I think we have 13 days, but I'm giving you 10 lessons. So that gives you 3 extra days to finish up anything that you might need to finish up. Okay, so good luck with this. Email me if you have any questions or concerns. Remember, we're going to do ESA not once, but twice. So your first step, get a variable alone. Second step, plug that into the other equation. Do your ESA, get an answer, and then plug that into either one of the equations and do ESA again. So it's ESA not once, but twice. Good luck.